Okay, so here's a new problem. Here's a matrix M given here. It's a 2 by 1, 2, 3, 4. It's a 2 by 6 matrix. And the problem is, what is the column rank of M? And so you have to remember what the column rank is. So the column rank of any matrix equals, and this is the dimension of column space. So that at least reduces the questions. What is, you know what a dimension is, right? It's the number of vectors in the basis of column space. So what's column space? Well, column space equals the span of all the columns as vectors, of all columns as vectors. So it'd be like A times 1, 0 plus B times 2, 3 plus C times this one plus D plus E plus F, right? It'd be all those vectors where A, B, C, D, E, and F are all arbitrary vectors. So that's the column space. So what is the column rank? Anyone have any ideas? Well, let me ask you this then. What is the relation, relationship between column rank and row rank? Row rank, of course, is the dimension of row space, and row space is the span of all the rows treated as vectors. So do you know what the relation is between the column rank and the row rank?
The dimension is the same.
They're the same. Okay, so that means that the column rank and the row rank are the same. So you can answer the question what the column rank is by finding the row rank, right? So then the question, so you can find the answer. So what is the row rank? So how do you find the rank of how do you find the row rank of a matrix? Shruti disappeared. That question was too much for her. Probably had other issues. Probably we'll rejoin, probably Zoom issues. So anyone else have, well, the row rank, right? What is the row rank? The row rank is the, well, it's the number of vectors it's the number of vectors with basis for row space. Now here's the key thing. Gauss's method makes the rows of a vector linearly independent. Since they span the space, the number of non-zero vectors in echelon form of the echelon form of M equals the dimension of row space, so it equals the row rank. Right? So is this matrix in echelon form?
Yeah.
So how many non-zero rows does it have?
It's not,
excuse me,
it's not.
how many non-zero
Oh,
rows?
I mean, two.
It has two. So the row rank is two, which means the column rank is two. So the row rank of M, because M is an echelon form, the row rank of M equals two, which equals the column rank. So if you have to find the column rank of a matrix, it's going to be easier here because there's fewer rows than columns to find the row, to find the row rank, because we have a method to do that. We put it in echelon form. And so since the row rank is equal to column rank, which equals what you call the rank of the matrix, this is a rank 2 matrix. Okay, is that okay? Questions? You guys can hear me okay, right?
Yeah.
Okay. So let me just